background concepts of interactive multi-objective optimization so that we may understand better the rest of the tutorials and the rest of some of the talks. And I am, as Vavuska already mentioned, Giovanni Misitano. I'm a doctoral researcher here at the University of Jyväskylä. Kaisa is my supervisor, so very same group as here, naturally. And I'm one of the main developers of DESDEO. And I will be hanging around during this forum, so if you have any questions regarding DESDEO, I'm very happy to answer. When it comes to our tutorial today, we'll start with technology and some background concepts. And then we'll go into DESDEO, talk of the so-called core packages that we have. And then we'll also talk a little bit about this so-called DESDEO ecosystem, tell you what this means. So as already said, we'll go to background concepts and then we'll get in DESDEO itself. So some terminology. In multi-objective optimization problems, we have multiple conflicting objective functions, which are functions of so-called decision variables. The thing here is that these objective functions, they are conflicting, so we cannot optimize them simultaneously. When it comes to the feasibility of the solutions, we have the feasible set for the decision variables, which is defined by constraints, which I will talk shortly about on the next slide. And when we talk about the image of feasible decision variables, we talk about objective vectors. I will also talk about solutions, but what I generally mean about solutions, I usually mean the objective vectors or the image of a solution, X in S. With constraints, we may mean a couple of things. First of all, we might have box constraints, the decision variables, which are basically upper and lower bounds that the variables may vary between. But we also might have constraints of the equality constraints and also inequality constraints, where H and G might be some function of the decision variables X. And when we have feasible solutions, we have a special set of those solutions that we are interested in, and those are so-called Pareto optimal solutions. You can find the definition on the slide, but the intuition is that when we have few Pareto optimal solutions, or actually the images of the solutions, then objective vectors, we cannot switch between those two Pareto optimal solutions without having to trading off, at least in regard to one of the objectives, which means that we may improve one of the objectives in the solution, but we will have to impair or deteriorate one of the other solutions. And of course, the set of all these Pareto optimal solutions is the Pareto optimal set. And moreover, we may also define the so-called ideal point and the nadir point for the Pareto optimal set, which respectively, when we are minimizing, the ideal point will tell us the lower bounds of the set, and the nadir point will tell us the upper bounds of the set. And in this talk, when we say we optimize an objective function, we mean we minimize it, just to keep things simple. And this is basically what I just told you, but in an image formative reason for you to understand. And because this is a tutorial, the audience is welcome to ask questions at any point. So before we go to the following topic, I would ask the audience if anybody has any questions or any clarification you'd like to have at this point. All right, let's continue then. And the thing with Pareto optimal solutions is that we cannot really compare them alone mathematically. And moreover, we assume we need a decision maker who is able to provide preference information so that we may find the best possible solution or the most preferred solution for said decision maker. And we also assume that decision makers are often, or actually always, interested only in Pareto optimal solutions on the basis of rationality, because why wouldn't you prefer a Pareto optimal solution to a non-Pareto optimal solution? And With interactive or with multi-object optimization methods in general, the point is to utilize preference information in one way or another to find the most preferred solution. There are methods that do not use preference information. We are not really interested in those. Out of these methods, we are especially interested in interactive methods where preferences are given by the decision maker during the optimization process iteratively. And interactive methods themselves may be divided roughly into scalarization methods and evolutionary methods. In scalarization methods, the idea is that we scalarize the problem so that instead of multiple objectives, we end up with one objective function, which we can then optimize for a Pareto optimal solution. With evolutionary methods, we have a so-called population of solutions that we can improve simultaneously, which will give us a set of solutions which, generally speaking, are not really Pareto optimal, but they might be very good. Hopefully, they are very good approximations of actual Pareto optimal solutions. So they are evolutionary methods are based on heuristics. And yes, with preferences, they come in different forms, and different decision makers might prefer to give or express their preferences in different formats. I have given a couple of examples on these slides, and one of the most common ways, at least in my work, which I have encountered, is this reference point that a decision maker can give aspiration levels for each objective function, and these aspiration levels tell which kind of values the decision maker would like to achieve for each objective function. Then we also have simpler references like upper and lower bounds or reservation levels for different objective functions and so forth. And again, interactive methods in this kind of pictorial format, if this is easier for you. But really the point is that the decision maker gives preferences go into interactive method. The interactive method does its magic, then we get some solution or solutions. The solutions are seen by the decision maker and so forth until the decision maker is happy with the found solution, and then we stop the method with the found solution. During this process, the decision maker is able to learn about the problem, basically what is available, what can be achieved. They can also begin to learn about their own preferences. So actually find out what they prefer and what not. Okay, any questions about interactive methods that you would like to ask, or something you think I should have mentioned? If not, then we may continue to DESDEO. So I hope that at least some of you have already heard about DESDEO, but if not, DESDEO is an open source modular software framework for interactive multi-object optimization. It's openly available and openly distributed, and it consists of so-called core packages. But we also have some other packages that I will talk about later. If you remember, this was about the ecosystem that I mentioned at the beginning. And the thing with packages is that they consist of modules which are kind of specialized collections of code that achieve certain tasks that we need to achieve in interactive multi-object optimization. We'll go through these packages one by one, and I'll tell you a little bit about them. But before we do that, somebody might ask that why do we need DESDEO? The motivation behind DESDEO is basically that we would like to have as many interactive methods as possible under the same framework so that we may compare them. We might switch between them if needed. And it just makes life easier for a researcher, but also for somebody who wants to apply these methods, because as I said, different decision makers might want to give preferences in different formats. And usually different interactive methods work with different preference information. And this also makes it easier for people to experiment with interactive methods if need be. And of course, having a code base with at least a decent documentation is very important for people to be able to apply interactive methods and also develop their own by utilizing some pieces from here and there of already implemented methods from where the modularity framework. And we'll start with the core packages, and the first core package is DESDEO problem. And DESDEO problem, as the name suggests, is all about modeling problems. And we can model our own problems based on data, based on political formulations, but we also have some tools for surrogates. For example, if we have data, we want to model a problem, we can use, for example, Kriging models or Gaussian processes, as some people know them as. And of course, we have also already implemented some test problems for your convenience to start utilizing methods if you don't have your own problem necessarily. And this includes, for example, the TTL set test problems suite that some of you might be familiar with. Already mentioned that support the problem types currently are analytical problems, database problems, and simulation-based problems. And I will mention the minimum viable product at the end of this presentation, and that is something where we also plan to include hopefully mixed integer problems as well, because those happen to be very popular in many fields. But right now we support continuous variables. Then we have DESDEO tools. DESDEO tools is a collection of different tools and utilities that might be needed generally in the framework for example, modeling problems, or in interactive methods, in scalarization-based methods, or evolutionary-based methods, or so forth. So it's a collection of useful things that we might need. And it contains many scalarization methods, it contains mappings to transform multi-object optimization problems from one form to another, and so forth. It also has interfaces to different solvers, mostly single objective solvers that are needed in solving scalarized problems. Then we have DESDEO MCDM. The name comes from multiple criteria decision making, and this package is dedicated to scalarization-based methods. And we also have so-called trade-off-free methods and navigation methods in this package. If you have heard about any Nautilus method, you will find most of them in this package. And so methods to approximate the paradigm front are needed in some methods. They can be found in this package. And of course, various utilities that might not fit DESDEO tools because they are specific to scalarization-based methods can be found in the MCDM package. Some examples of implemented methods are synchronous Nimbus, eNautilus, Nautilus Navigator, and the reference point method, but there are others as well. Out of these, you can come during the coffee breaks. There is a screen I set up next to the posters, right behind the corner there. And you can try yourself Nimbus, eNautilus, and the reference point method if you want, with kind of this toy problem where you can find out your ideal dog. I will tell you more of this. Come visit me next to the screen. And yeah, with Nimbus, we have, just to give an example of these methods, Nimbus requires classifications of the objective functions, which means that we can say that we want some objectives to improve, some objectives to improve until some limit, some objective might get worse until some limit, some objective might change freely, and then some objectives might stay as they are according to your preferences. This is just some arbitrary objective functions. You can usually imagine what they mean. And with trade-off-free methods, which I mentioned, for example, eNautilus as depicted here, the idea is that we start from the nadir point and we approach the paradoxical front gradually. In each iteration, we get this set of candidate solutions from which the decision maker can choose what they prefer most, and then we get a new set of candidate solutions based on the previous choice, and so forth until we reach the paradoxical front. And the idea, as you can see, we can improve each of the objective functions. In this case, we have two. We can improve them in each iteration. So here is where the name trade-off-free method comes from. And this idea has been applied in various ways in different methods in the Nautilus family of methods. Then we have DESDEO EMO, the last but not least core package I will talk about. And as the name suggests, this is about evolutionary multi-object optimization. It has a lot of modules because, well, it so happens that not a lot of stuff has been ready-made for, specifically for multi-objective evolutionary optimization necessarily. I won't go through all of these, but just to give you an idea, there are tools, there are basically different evolutionary operators that are needed for solving multi-object optimization problems. There are various utilities and tools to handle populations, which are very central to evolutionary multi-object optimization and so forth. We also have some surrogates models that are very specific for modeling multi-objective evolutionary problems as well. And to give you an example of some of the methods we have there, we have plenty. This is just some examples. And I bet most of you are familiar with the NSGA3 method, or at least the NSGA2. NSGA2 we don't have, but we have NSGA3. And we have an interactive version of it. We also have a reference vector method, RVEA. And yeah, these are what are currently found in the framework and will come. And together, one might utilize these packages as one wishes or selectively just to accomplish certain tasks. If one needs to only implement or use organization-based methods, then one just needs the MCDM package and the problem and the use package. No need for the IMO package in that case. So that's the idea. One can selectively use whatever they need. And this also enables us to, DESDEO enables us also to hybridize methods. What this means is that we might use an evolutionary method to find an approximation of the paradigm front, and then we can use the approximation in some scalarization-based method to make the process faster if we have a very demanding problem. But if you are interested in this concept, we can talk about it more later as well. Okay, this was the DESDEO core packages. Any questions thus far? Yes.
Some slides, there was a definition of different types of problems, analytical, database. Could you please give an example of this one, some use cases?
So
actually just the problem to distill from this category?
Yeah, so examples, analytical problem, it means we know how the objective functions are defined, right? We have fx equals something, we know that work. With database problems, we might have just raw data, and it might not contain any kind of objectives, really, but we need to contain them somehow. So it means that we can model the objectives based on data. We can use some machine learning based surrogates, for example, to model objective functions based on the data. This is often done in collaboration with decision makers or domain experts who know more about the problem that the data is about. So in other words, this is basically a black box of them that we end up with. And simulation means that we have a simulation that produces the data, or we might also simulate the objective functions directly. That's sometimes also the case. So if it's just data that comes out, then it's basically a database problem. We can talk about online and offline database problems. Online means that we get new data constantly and we can update or surrogate. Well, but then we have offline that we just have some data we need to use. We might not get more of it necessarily. So yeah, I don't know if that answered your question.
Yes.
Okay, good. Anything else? Please.
One thing bothers me about this slide when you show the decision maker and interactive.
This one.
Yes. For me, the whole system, which is represented on the slide, is an interactive method.
I agree with you.
Yeah.
I see it as an interactive process, and the method is just part of it.
So isn't it so that we can drop the word interactive?
Not necessarily. In some cases, I would, but not in all cases. For example,
I don't understand what kind of interaction is interactive method. The method interacts with the decision maker.
Hmm.
That's all. So it gives preferences, and there is a method to respond to those preferences, but not in interactive way. Given preferences, and there is an answer. Given preferences, there is an answer.
Yes, that's interaction.
Okay, but this is the whole loop, the big loop.
Yes.
There's no small loop inside interactive method.
Yes, like I said, I would describe this as an interactive process. And when we have methods inside an interactive process, we usually call them interactive methods.
Okay.
But if we talk, for example, about, I think navigation methods are a good example of like a method that you cannot really just use as an a priori method or an a posteriori method. You really need to interact with it.
But it's not so that you give preferences, say, it's a set of preferences, there might be a vector or something like that,
Yes.
and you get a couple of answers. You get one answer. There is no interaction with those preferences. So I think that the clear picture would be this interactive process. You can call it the whole slide interactive method. But inside that, there's no interaction, there's a method.
Okay.
Just to clarify, it doesn't change much, but well, for having a more clear picture, what is
Sure.
being done.
Sure.
Okay.
Any other questions? Yes, please.
What about this continuous variables? What about, have you been trying to solve, for example, voting methods or aggregation methods? They are discrete.
For discrete variables, we are working on it.
Yes, yes. But
With this aggregation, I'm not sure what we mean.
I mean that voting, it's you say you vote, for example, positional methods, which can be used also in criteria decision making. So what I'm trying to ask, it could be this interaction method. You're using voting methods. Yes or no, no continuous variables. I'm not an expert on this, but I just want to ask. You are telling that we are working on it.
Yeah.
So when you vote, you say yes or no, and it's.
I think
it's
you
not
are talking of MCDA
Yes.
right now, so multi-criteria decision A.
Okay.
And that's fine, but it's not exactly what we are doing.
Okay.
There is, of course, when we deal with discrete variables, then there might be this kind of overlap a little bit. So here I would say that you are saying is multi-criteria decision A. But here what we mean is discrete variables. So when we have variables, the variables might be integer values. So that's the thing that I'm trying to do here. Anything else? Yes.
Solutions this framework generates. Is this mathematical that is secure that is accurate, or it's just a numerical reason that optimality is not secure?
Yeah. So with scalarization methods, we often use scalarization functions that have certain qualities, desirable qualities. And one of them is when they are optimized, we have some guarantee of the Pareto optimality of the found solution. So there we have this kind of mathematical insurance for the found solutions. But with evolutionary methods, we use heuristics, and really we usually use heuristics for programs where we don't have the necessary information to guarantee any kind of optimality, in which case we can only say that we have at best found approximations of the type of solutions. So with scalarization, MCDM methods, depending on the problem, we can have this guarantee of optimality, but in MO methods, evolutionary methods, we usually don't, because we use them for problems where we don't have this information that we would need to guarantee anything.
See, so in general, the DESDEO framework can generate lots of these solutions based on the methods or algorithm you are using.
Based on the method and based on the problem that we are solving, but usually the type of problem dictates what method we are going to use also. Not just the preferences of the decision maker, but it's also about problem itself.
Question, does this that decision maker has to be certain?
We usually assume they are a person, but as long as they are able to provide preference information, then they can be regarded as a decision maker. But no, usually it's a person, but when it's not, then we talk about artificial decision makers, which we'll hear something about in our talk later this forum.
So intelligence is required for the decision.
Sorry?
I say it doesn't not has to be a person, but intelligence is required.
Intelligence, yeah. I would say it's required that whatever we call a decision maker can provide preference information. But really what we really deal with human decision makers. And when it's not human, then we call it an artificial decision maker. Kind of very rough division. Okay, now we'll have to continue. Okay, a question. Okay, I really like questions.
For the black box, we have the interactive method, I mean, in the whole decision process slides. And there, you mentioned that this still includes like the scalarization and also the evolutionary. So I think that for the scalarization, you just tune your model, tune the different parameters, and then solve the optimization model again to get the solution to the decision maker for the feedback, right?
Yeah, the preferences that we get are basically what changes during different iterations.
Yeah, sure.
Of the method.
And then for the evolutionary, I wonder whether you use like warm start or cold start for the different feedback. Is the decision like stepwise, interactive, or like?
It's similar. It depends a little bit, but often we can evolve the population for a set number of iterations. Then we interact with the decision maker. They can give preferences, they can see the solutions, then give new preferences based on what they see, and then we can continue evolving the population. With regarding warm or cold start, of course, if we have any information that can help us in having a warm start, then of course we can utilize it. But often we don't, and then we just use something like hypergroup sampling for the initial population and hope we get something sensible.
Just to add to that, the Latin sampling is just for the initial generation of the population. But once we are within this loop, let's say the end of the first iteration, we have some population, and then the decision maker gets a new preference based on that. We can continue evolving that population itself, and the evolutionary algorithm will then slowly change that population to match that preference. But there are some algorithms that can do this evolution in a nice way. There are some other algorithms that basically break down if the preferences are too far away from the solutions, in which case sometimes we may need to regenerate. Usually we try to keep the same population alive for as many iterations as possible.
Thanks. I'm just wondering whether it can be used for long-term, like with multi-stage decision. For example, each year you throw a new decision for the decision maker based on response and so on.
Things like that can be done, but then you're basically building on top of this loop. It wouldn't be just the method, it is something building on top of that.
Yeah.
Okay. Let's continue. A couple of slides left, and then we won't have to look at my page anymore. All right. So next, the DESDEO ecosystem. What this means, this is everything outside the core packages. And something that is very central to interactive methods is the interface that they are utilized through. And one thing we wanted to achieve is that Python, because DESDEO is implemented in Python, it's not really the best software framework for implementing user interfaces. So we developed a so-called application programming interface, which allows us to interface the methods we have in DESDEO so that they may be utilized by any application that can handle basic HTTP or hypertext protocol messages. So it allows us basically to use DESDEO in any other programming languages, many other software frameworks than just something that is Python-based necessarily. And to give you the big picture, we have DESDEO, the core packages, and then we have a DESDEO web API, which is implemented mainly in Flask, and this is what we call the backend. And then we have a front end for the interface that the decision maker or the user, whoever is utilizing our methods, interacts with the method through, and that is implemented currently being implemented currently in a web framework called Svelte. We have the version that we can test behind the wall that is implemented in React. It's an older version, but we are now building on lessons learned and doing something that is more maintainable and more expandable as well. And DESDEO components, this has to do with the fact that interactive methods really require specialized visualizations that have the ability to have really this kind of interactive properties that we can really interact with the data that is shown. So we can select, we can brush, we can link visualizations and so forth. And really, it's kind of a silly thing, but you cannot find much that has already implemented these kind of features, even though one might imagine that, of course, these are basic features. They are however really not. So we have to implement our own mostly. And everything is available, as said, openly. And if you're interested, you can do this code yourself. As mentioned, all the React-based interface is deprecated, so it's not really updated anymore. It's still utilized somewhere, but not really something we are actually developing anymore. This web UI is the name of the newest package that utilizes Svelte. And DESDEO, as said, is under active development, and we are building towards a so-called minimum viable product, where we have many things we have promised to deliver, including the mixed integer problems, but also this new interface that I have mentioned. And we have the deadline at the end of August. And anybody is really welcome to contribute to DESDEO. Nothing is stopping you. It's open source. It's openly available. If you have ideas, you can just come and implement them and come work on this together with us. And next, we'll have tutorials by Binder, and then by Juuso, I think next. Yes, and then Binder, and we'll see more DESDEO in action and what it can do. Of course, for news and resources, we have the DESDEO website. Luckily, DESDEO is such a name that if you just Google it, you should find it first result. But if not, then you can find the web URL there. And then we have references. So thank you very much for your patience. And if there are any more questions, we maybe have time for one, but then we have to move on because we are a very active audience, which is very